Hello everyone, my name is Naila Morita Syarafiun with student ID 2024-32051. Okay, in this video, I'm going to present my machine learning practical report. Our main focus today is the implementation of the linear regression algorithm using a real stat dataset. And I will walk you through the technical steps from data preparation and model training to evaluation, explaining it deeply cell by cell. Okay, let's start with the first cell. The most crucial step is loading libraries. We use NumPy for numerical computing and Pandas for tabular data manipulations. For visualization, we use Matplotlib. The most important part is the last line, where we import scikit-learn. We use train test split to divide the data. Linear regressions as our main algorithm and evaluation metrics like mean squared error or MSE or R2 score. And this library is the industry standard for developing Python-based machine learning models. Okay, moving on, the second cell is reading the dataset. So in the second cell, we load the raw data from a CSV file named realestate.csv. By using the dfhead function, we can see the first 5 rows of our data. And as you can see, there are several important columns such as transaction date, host age, distance to the nearest MRT station, number of convenience stores, and location coordinates. Our target is the last column is Y house price of unit area. And understanding the data structure early on helps us decide which features are relevant for the model. Okay. In the third and fourth cells, I performed a descriptive analysis using dfdescribe. We get a statistical summary like the mean, standard deviation, and the minimum and maximum values for each column. For example, we can see that the average house age in this dataset is about 17.7 years. Then, dfinfo in the fourth cells give us an overview of the data types. And here we see that most of the data are float 64 and integer 64, meaning our data is already numeric and ready for processing without needing manual label conversion. Okay, the next stage is the data cleaning in cells 5 through 7. Okay, first I check for missing values using ISNA point sum. It turns out the data is quite clean with no null values. However, in cell 6, I decided to drop the number column because it's just an index and has no statistical correlation with house price. And I also run the drop duplicates function in the cell 7 to ensure there is no redundant data that could make our model biased. And high quality data is key to an accurate model. Okay, in cell 8, I separate features X and target Y, and variable X contains all columns except the house price, while Y only contains the price column itself. Next, in cell 9, we perform data splitting, and I divide the data into 80% for training and 20% for testing. And using random stat 42 ensures that the data split remains consistent every time the program runs. This step is vital to test how well the model predicts new data it hasn't seen before. Okay, and now we're reach the core of this project is building the model in cell 11. I analyzed the linear regression object and trained it using the training data with the fit function. And this is where the algorithm learns the linear relationship between house features and their pieces. Once the learning process is finished, in cell 12, I use the model to make predictions of the test data, and we will compare these predictions with the actual price to see how the model performs. Okay, in cell 13, we evaluate the model using statistical parameters, and the result show an MSE of 53.5 and R2 score of approximately 0.68 and R2 score of 0.688 means that our features like house age and location can explain 68% of the variation in house price. And we can also see the intercept and coefficients for each variable. And these coefficients show mathematically how much each feature affects the increase or decrease in house price. And finally, in cell 14, I present a visualization using a scatter plot. And the horizontal axis represents the actual values, and the vertical axis represents the predicted values. And ideally, these points should form a straight diagonal line. And from this graph, we can see that the model's predictions follow the actual data trend quite well, even though where there are few outliers. This visualization makes it easier to explain technical results to a wider audience. And concludes the explanation of my linear regression program for real estate price prediction. In conclusion, this model is quite good at capturing basic house price patterns, though it could be further improved with more complex algorithms. Thank you for watching. I am Naila Marita Chakravyun, and I'll see you in the next presentation. Bye.